This video is going to go over, the first thing I'm in right now is the AP Calc Bible, page 18. And I think probably example 1, I'm hoping that went okay for you. What you have to make sure you do is separate the variables. So the y's have to be with the dy, the x's have to be with the dx. Once you do that, then you can integrate both sides. Now once you get to this point, typically they won't write the answer like that. What they'll do is multiply through by possibly, a common denominator you could see them do, or to get the answer that is listed, they just multiply both sides by 2. Now technically, this C1, if you multiply it by 2, you're going to get this new C value. And you can definitely put that down. If you don't, I think that you'll be fine as well. Now, example 2 is a little bit tougher because you're taking that answer and you're finding the particular solution. So C equals 7 probably wasn't an issue getting that once you put -5 for y and 3 for x. The problem comes in if they want you to solve it for y. So here we're just solving for y squared. Now, in order to figure out if we want the positive or negative square root when we square root both sides, we want to see which one's going to give us a true statement. So if we put 3 in for x, in order to get -5 out, we need a negative in front of that square root. That has been on the last few AP tests that I've seen where they had you figure out which solution. So there were 2 solutions and you had to figure out, which one that initial point that was given lives on. And it's just a matter of plugging it in and seeing which one works. Example 3, now this one we want to be really careful because there's a 6, an x, and a y. Now when we bring the dx over to the right side, there's a 6 and a y that aren't x's. Well, the 6 I definitely want to leave there. I have to take the y to the other side, but this is a case I see every single year. And what I'll tell you every time is to make sure if there is some other number, a scalar, always put it away from what you're solving for. If not, it makes it much more difficult because if you had it on the left side and you had 6y, well, you should take out a 1, 6, but some people won't, and they'll ln that, like they'll integrate it, but then not use u substitution. It just creates all kind of errors. So if we put the 6 on the other side away from the y's, it'll make it much easier. Now once we get ln absolute value of y equals 3x squared plus c, in order to solve for y, we're going to exponentiate. So that's why I made e the base. Then those sides of the equation become the exponents. Now it gets a little tricky here, and this is where we tend to make some mistakes. We'll have the absolute value of y equals, remember rules for exponents? If they have the same base, you add the exponents. So if I want to separate e to the 3x squared plus c, it's going to be e to the 3x squared times e to the c. Now e to anything is always positive, so the absolute values on the y we can lose. And then e to the c, a number to a number, is just some number. So that's why that becomes c e to the 3x squared. And then we can put in the initial condition, 0 for x, 5 for y, to find out the final answer. Okay, and then average value, they were just reviewing that on the last one, so hopefully you remember that formula. Okay, so now I'm going to go back to, that was the AP Calc Bible, so I think I have the midterm packet here as well. So pages 9 and 10, specifically page 10, but I'm trying to look on page 9 to see what I would think we'd have the most questions on. These were all review of chapter 4 and 5. Hopefully they weren't too bad. You may on number 5 have gotten a little bit tricked when you had the du as 4x minus 10, but if you factor out a 2, then you'll see that you'll get the du if you attach a times 2 balanced with a 1/2. Okay, the differential equations at the bottom, separating the x's and the y's. taking the integral and then exponentiating, just like I did on that last one in the AP Calc Bible, to get this answer. So there are a couple steps you could go through here, a few more steps, which would be the absolute value of y equals e to the 1/3 x cubed times e to the c. And then e to the c is going to give us the c value here. And we can lose the absolute values because e to anything is always going to be positive. 7 was pretty easy. Just take the d theta to the other side and then you can integrate that, if you know those integral formulas. Number 8, now we're starting some word problems. This was a colony of bacteria is grown under ideal conditions in a lab, so the population increases exponentially. At the end of 3 hours, there are 10,000 bacteria, so we know an ordered pair, 3, 10,000. At the end of 5 hours, it was 40,000, so we know another ordered pair. So I know when it's exponential, I have my equation y equals c e to the kt. And then I'm going to plug in, I can use either ordered pair first. I'll put in the 3 for t, the c is 10,000. And then what I can do is write that equation as c equals 10,000 e to the negative 3k. Now why I'm going to have to do that is because when I don't know the initial values, I don't know what c is or k. So once I have that, now I'm going to go and put that other ordered pair in. 40,000 equals c e to the 5k. In place of c, I'm just going to do a little substitution and make it 10,000 e to the negative 3k. So then I can divide both sides by 10,000. Okay, so I'll get 4 equals, and then I add these exponents since they're the same base. E to the 2k, ln both sides, I can find out what k is. Now I can go back, plug in either one of the ordered pairs to find out c. When I do that, I will be plugging in this k as ln 4 over 2. So I used 40,005. The 5 kind of is off my PDF, so that is there. And so if I divide 40,000 by e to the ln of 4 times 5 over 2, I'll get the initial amount, which is what they wanted. Number 9 says, suppose that electricity is draining from a capacitor at a rate proportional to the voltage. So they give us this formula. To solve it, we'll multiply both sides by dt, divide both sides by v. Then we can integrate both sides. When we integrate both sides, we'll have an ln. To get rid of that ln, we can exponentiate. Again, several steps going on here where we're breaking this up into times e to the c. Sorry, I'm not very good with writing with this pen at all. So this was e to the negative 1 over 40 t, and then times e to the c. That e to the c becomes the c. We can lose the absolute values because that right side's never going to be negative. And then we can get v equals v naught, or you could say c, but it could be, since they were telling us use v naught for the initial value, e to the negative 1/40th t. Now, to find out the time it takes for the voltage to drop 10% of its original value, we want to know when is the voltage 10% of what we started with. So let's say we put in 100 here. Then we do 10% of 100. So even if we don't know it's 100, but we know it's v naught, this would be 10% v naught, or 0.1 v naught. When I divide both sides by v naught, regardless of what numbers I use, I get 0.1. Then I can ln both sides and solve for t. Okay, and so that was 92.103 seconds. And then the last one, number 10, a 200-gallon tank supports no more than 150 guppies. 6 are introduced into the tank. They give us the rate of growth of the population, where t is the time in weeks. So I took the dt to the other side first. Then I have this quantity. I certainly don't want to distribute first, because then I'm not going to be able to take the p to the other side with the dp. So I have to divide both sides by 150 minus p. Here's another case where we have an extra scalar. Keep it away from what we're solving for. We're solving for p, so let's keep the 0.0015 on the other side with the dt. Then we can use u substitution to integrate. We have to balance with a negative. There are many ways to go about doing this. but it is so much easier, instead of using properties of natural logs, just to divide both sides by -1. So when you divide plus c by -1, it's still going to be plus c, a constant that we don't know. It could have been positive or negative divided by a -1. It's still a constant we don't know, positive or negative. And then we can exponentiate both sides. So this is a case, and this is the type of question I've seen recently on the AP test when they have differential equations. It's a quantity, and they want students to be able to know you can't distribute and then get the p to the other side. You have to divide by that quantity. And then just knowing some things that will make solving a lot easier, like dividing by the -1, then you can exponentiate and solve for p. Then using that initial 6 guppies introduced to the tank at time 0, we can find out that C is 144. So this is a case where the C value isn't just what the value is when time is 0. So you have to be careful as these get more difficult. We'll see that that happens more often. And then once we have that equation, we can find out how long it'll take the population to be any number, in this case 125. So we'll do take 125 minus 150, divide both sides by a negative, and then ln both sides to get the time in weeks. Okay, I hope that helped. Please email me any questions that you have.